Hello, hello, hello. Notes 2, moles in Stoich. Today we're going to do percent composition. Percent composition. Percent is part over whole. Composition, what is it made of? So let's take the part of what it's made of over to whole, and we can figure out percent composition. That's basically what it means. Castle Learning, I hope your first Castle Learning went well. Don't forget your password, please, and don't forget your ID. If you have any issues, by all means, feel free to email me. So we're just basically going to do a ratio of relationships now that we found how we can count atoms better. Now we can look a little bit deeper into each of these compounds. Okay? So, calculating percent composition. We're going to need the gram formula mass, now that we know how to do that. Okay? We're going to do 1 times 40.8. Well, that's 40.8. Just so you know, in the notes, right now we're using our decimal places. When I give you these problems, I am totally cool if you round them. You'll see if I did the rounding that now and we did it at the end, we'll see if the answer is pretty much the same. So 35.453 times 2, 70.906. Add them together, 40.08. I get 110.986. Come on, point, go away. And then can we say, 986, can we say 111 grams per mole? Now that's, of course, of this, the whole thing. So I need the whole, because I need the part, then I need the whole, right? So let's go to the next page, and we'll see a problem now that does all of it. First of all, I believe, isn't this table T? Back page of your periodic table, table T is where you have all the equations we need to use. So table T, you'll find this equation. Percent composition is the mass of the part over the mass of the whole times 100. There you go. For our sake, this whole to the nearest tenth, yeah, probably about right. But if we round ahead of time, we might get a nice easy number. So what is the percentage by mass in carbon dioxide of carbon? It says carbon in the carbon dioxide. So let's do carbon dioxide, just gram formula mass. I have 1 carbon times 12 is 12 grams. And then oxygen is going to be 2 times 16 is 32. Total is 44 grams. So now that's the whole. The part, 1 carbon is 12 divided by, that's an ugly 2. Let me erase and let me make a nicer 2 because that one's ugly. Mr. Milks, please don't make so many ugly 2s. 2, 12 over 44 times 100. I made a yucky times sign. Sorry about that. These smart boards aren't so smart, are they? 12 divided by 44 equals, I have times 100 is 27. I'm going to round up the 27 to 0.3%. Okay, 27.3%. And now, what is the percent by mass of nitrogen in this beast? Okay, well, I see 2 different nitrogen atoms. So let me just go right ahead and say nitrogen is going to equal, look up the mass on my periodic table, it's 14, and I have 2 of them, that's 28. I'm going to do this ahead of time, so then this is going to end up being my part, and it's already pre-calculated for me. I have H, and I have 4 of them, times 1 gram, it's going to be 4. Then I have oxygen, that's going to be 16 times how many? 3 oxygens. That's 18 and 30 is 48 grams total. So now I have 8 and 8 is 16 and 4 is 20. 2, 4 is 4 and 4 is 80. Total is 80 grams for the whole thing. And my part I already figured out is 28 of just the nitrogen. So I can say my part is 28 over my whole, which is 80, times 100 equals. Handy dandy calculator. 28 divided by 80 equals 35% times 100. So I got my 35%. Okay, that's how we do it. That's simple. Gram formula mass helps. So now, percent by oxygen and magnesium oxide. I'll help you set this up. Ready? Mg. O. Charge on Mg is +2. Charge on O is -2. Crisscross those down. Wow, look at, we're using all our skills, Mr. Milks. That's Mg2, O2, but then I gotta need to reduce these. We're gonna get Mg, O. So now you can finish this. I got Mg, I got O, and I have one of each times their mass. So I'll let you look up their masses. Okay? You look up their masses, get your answer, add your answers together to get the total, and then take your part divided by the whole, and you're good to go. Okay? If I look on your paper and I see the circle and these lines and stuff, then I'm going to know that you're not really listening to me when I told you I want you to do it, okay? Which is something I really want you to start doing. If you don't do these things out, I'm not going to be giving you guys full credit on the homework anymore. A hydrate's a fancy name for it's a crystalline with water in it. Hydrate sounds like hydro. So we just noticed that the water molecule is built in, and without it, it's called anhydrates. Just another term. We won't hear that much. But the thing is that I just need to be able to know how to count all these atoms. So I have 2 sodiums, I have 1 carbon, I have 3 oxygens. And then I can either do the mass of water and multiply it by 10, or I can say I have 20 hydrogens and 10 oxygens. Okay, that's just what you need to be able to do when I calculate the gram formula mass of these things. It's a little bit of an extra step. And so here's an example. Na2, I have 2 NAs. It's got a mass of 23 because I'm going to go ahead and round. Carbon is 12. Oxygen is 16. And once we do this a lot, sorry about the tails on this. My smartboard's acting a little funny. I'll redo those real quick. 12, 16. If I do out oxygen or water, I'll do it over here. Hydrogen is 2, so 2 times 2 is 2. And oxygen is 16, so if I add 16 to that, I get 18. You do that enough times, and you'll know that water is actually 18. And that makes life a lot easier when you just do it this way. 2 times 23 now is 46. 1 times 12 is 12. 3 times 16 is 48. 10 times 180, or 18 is 180. Here I go getting ahead of myself. So the mass, now I have to add it all up. Let's see, 8 and 2 is 10, and 6 is 16. I have 4, 5, 6. 6 and 4 is 10, and 8 is 18. And 1 and 1 is 2. 286 grams for 1 mole of this particular thing. That's the gram formula mass of the hydrate. So now it says on the last page, we want to find out what is the percent water. So the percent water by mass of that last thing is going to be, the part was 180. So that's my part, 180 grams. Sorry, my smartboard is really acting a little funny. It really needs to be redone, but I'm not going to do it while I'm making the video. We're just going to write a little slower, and you guys are going to bear with me. Technical difficulties. Go away. 180 is my part. Let's go back. And my whole now is 286. 286 times 100 is going to equal, handy dandy calculator, 180 divided by 286. I know you got the answer already. You're just waiting on me to catch up. I have 62.9% water. So there's a lot of water, more than half of it's water, and that makes sense. 180 is bigger than half of 286. So good, math works. So practice. Percent by mass of water in this beast. Okay, I'm going to help you with one thing. Ready? I have 1 Ba, I have 2 Cls. If I do this, I have 4 H's and 2 O's, or I can do water times 2. Your call. But you need to figure out what is the percent of water. So the water mass is going to be your whole. So you might want to do that with the 18, right? I would keep it at 18. Let me see you do that practice one by yourself. Which species contains the greatest percent by mass of oxygen? And we are running late, but I'm going to try and go through this fast. Ready? I'll do 2, you do 2, and then you'll come up with the answer. CO2, percent by mass. I have carbon is 12, and 2 oxygens is 32. So that's a total of 44. And then oxygen's total mass is 32 divided by 44 times 100. Okay? You're going to get me a number there. And I'll do MgO. MgO, magnesium is 24. And 1 oxygen is 16. So it gives me a total of 40. So that gives me oxygen is 16 over 40 times 100. I instantly know that this is going to be less than this. Okay, obviously this one is more than this one. So I know it's not this. You guys do this one and tell me which one total is the greatest percent by mass of oxygen. Okay, you guys do the practice problems. Now, when you're done with those problems, you can practice some more. Practice pages 4 through 5. Then you need to do 5 more quick questions titled point or number 2% composition. And we are done now with this. Guys, please make sure we do the practice packets. This is one of those things where, remember, practice doesn't make perfect. Practice makes permanent. I need you to keep doing these little tasks along the way so that you get good at them. And eventually, you'll be able to, pass your quizzes on the first try. See you guys. Sorry this one ran so long.